one of the members wrote a piece of code, and if it doesn't run, how do you know what's wrong? That was basically the question. And this is to look at a way of, as the program runs, to see what's happening. So let me just share the screen and we'll have a look. The Arduino Ide. And basically what the member has done within the main loop, I've shortened it all just to show the part we want to talk about, is taking an analog reading from a trimmer, mapping it to a different set of values, and then he's applying 1, 2, 3, 4, 5, 6, about 9 different formula to it. And he'd worked it all out on a piece of paper, but he wanted to be sure that what he was doing did in fact give him the correct results. So how would you know? Well, one of the ways is that if you go up to the tools in the Arduino IDE, there's a couple of options here. One's called serial monitor and one's called serial plotter. So we'll look at the serial monitor first. To use it, you've got to go up in your setup and put that line in, serial begin. So the serial begin is creating the link between your Arduino and basically your USB socket of your PC. And the figure in the brackets is the speed, the baud rate at which you're sending the data. Right, so if you add that one line, you've now created a communications link between your program and the computer itself. And then we can, having worked out all the calculations, we can add extra lines in. So if you look at the very first piece here, it says serial print, also a capital S, and print out a piece of text. Or you can print out an actual value, because the first thing we wanted to look at there was X, or X new, or CW, or AW, and so on. So we can now have a series of printouts saying, that's what I read as a raw value. That was after the first calculation. That was after the second calculation, and so on. And you can then check that these figures that you worked out in a piece of paper, in fact, are correct as the program runs. So if I go up now and I just check my tools, I'm going to a nano, I'm in COM3, right? I'm going to program the nano. So the Virgin Nano there, it's now been programmed by that small piece of code. And once it's fully written, that's it. If I go up to the tools now, in the left-hand side, you'll see it running. So these lines you're seeing here are just a result of these. So you now can compare these figures in practice with what you had when you were doing it on a bit of paper. And not only that, you can set the scroll on or scroll off. The trimmer's reading 171. It's reading 118. I'm changing the value of the trimmer, and you can see the results of what you'd expect. It's a form of pulse width modulation that's going on here. And we're working out the time high and time low that's going to go out to a loco or a motor. So I thought that was very worthwhile showing you. You can have as little or as much as you want. If you only wanted to show what was happening, say with the time high and the time low, you could delete these lines. And all you want is the end result what I expected. I can reprogram it now. And once it's fully loaded, go up to the tools, serial monitor. And that's 4,000 microseconds, 2,000 microseconds for the time high and time low. If I change the values, it's 4,000 and 5,000 and so on. So it could be any piece of text to be descriptive, as in here, or it can be an actual variable value as the program runs. Quite often you do both. You're telling yourself that that variable called high W, high width, is coming from the time high variable. Very, very useful. There's also another option, I said, called serial plotter. So let's, if I go to the plotter, oh, I have to close this first. I'm seeing in real time a plot of me actually changing the plot settings. And you can see what they do over time. So you can see what happens when I put my pot to full clockwise. What reading do I get when I put it to full anti-clockwise? When it's roughly halfway, what do I expect? And it's telling me the values down this axis, what the values are. In this case, I'm only showing a variable as it changes with me doing it manually, but you might do the exact same thing when your program is keeping changing values. And you can see whether the value goes out of bounds, it goes into negative territory or whatever. Two little utilities, one to show in real time a graph, the other just to print out values. If you haven't come across it before, I think it's a godsend when you're trying to debug your own programs. The only thing I forgot to say is it's up to you. The code itself said it is running at 9600 baud. You have to make sure that your plotter or your serial monitor are also running at the same baud rate to get the correct results. Can you see down here?
Yes.
You can set the baud rate there.
Yeah.
So if I go there, it doesn't have to be 9600. That tends to be the most stable, so people use it for sending stuff out. So as long as you have your monitor or your plotter set to the same speed of operation of transfer, then it's going to work quite happily. The one thing I should also mention is use this for debugging purposes. I tend to leave the lines in, but commented out. You know, you put 2 slashes, it's commented out. Otherwise, it's going to slow the program down because it takes time to write from the Arduino to the monitor screen. And if it's time conscious, then every time it goes around the loop, it's taking time to actually write all those values to the screen. So I tend to leave them in, commented out, and it means later on, if you want to come back and make some changes, they're there to uncomment to make sure everything's still working. It's just a small piece of code, but it solves quite a lot of problems when people are trying to work out why the hell the program isn't working the way they thought it ought.